This is called hypothesis testing. This is making a decision. It's the other thing, as opposed to estimating. When we have to make a decision, how do we do that? Okay? Let me put this up. Okay. Making a decision. What we're going to do is set up a test and decide to accept or reject the hypothesis. Okay, that's nice fancy talk. What does it mean? You draw a picture. You draw a picture of a normal thing, and you set up your test. If you fall inside the confidence interval, then you say that nothing happened. If you fall outside the confidence interval, then you say something significant happened. Okay, now, there is some technical terms to this. You're talking about accepting or rejecting a hypothesis. Okay? We have in every test, there's going to be two hypotheses. You notice that it's not hypotheses. You change the IS on the end to ES. Okay. What do we have here? You have the null hypothesis. They write that as H sub 0. It's H with a 0 subscript and a colon after that. Okay? That's my null hypothesis. The alternate hypothesis is written capital H with an A as a subscript and a colon after that. Okay? The null hypothesis states that the status quo reigns, that no change has occurred. And so it's always going to be, we're going to be measuring something. So you're going to have the mean. The real mean is something. Let's say that we were testing something and the mean was 25. This would say mu equals 25. Okay? Our null hypothesis is that the mean is still 25. Okay? In other words, the status quo, nothing has changed. The alternate hypothesis, if we're looking at has something changed, we would write it as mu not equal to 25. Now, notice the equal sign is always above. It's in the null hypothesis. What you're trying to show shows up in the alternate hypothesis. Okay? This is what we call statistical significance. In other words, your test result came up with something that should not have happened if there was nothing going on. And so we say something significant occurred, that the status quo doesn't exist anymore, that we have evidence of change. Okay? Now, these tests, the alternate hypothesis could be either one-sided or two-sided. What do I mean by that? Let's see if I can put this up. Okay. One-sided or two-sided. Also called, in some books, it's called one-tail and two-tail test. A one-sided test tests for a directional change. A two-sided test looks for just change or difference. What do I mean? Up here, it's easy when you look at the hypothesis if you're reading somebody else's thing. This is a two-sided test because we're looking, has the mean changed in either direction? If this was a one-sided test, your alternate hypothesis would indicate a direction. So this would be mu greater than 25 or mu less than 25. If I'm looking to see if the mean increased, this would be my alternate. If I look to see if the mean decreased, that's my alternate. Now, if this is my alternate, some people write the other parts in there. So the null would be greater than or equal. But remember, the equal is always in here, and the purists, the math purists, always just use equal up here. And some people in some books will do, so if we're testing the alternate greater than, this is going to be less than or equal. If the alternate is less than, this is going to be greater than or equal. But your textbook and math purists use just the equal sign. But you can see it both ways sometimes. It means the same thing. Okay? So a two-sided test looks for, did you change in either direction? A one-sided test looks for, did you change in one direction? Now, let's see. I got some notes. This is very easy to pick up as a recognition skill. I put down here notes. Okay, the equal sign is always in the null hypothesis. The one-sided test will have a less than or a greater than in the alternate. A two-sided test will always have not equal to in the alternate. It's as simple as that. Okay, so if you see a greater than or a less than in the alternate, that's a one-sided test. If you see the not equal to, that's a two-sided test. Okay, what does that mean? Let me draw a picture. I'm not the greatest artist in the world, but some of you are more visual. If I'm testing at 95%, remember our confidence interval looks like this. We get 2.5% out here and out here. If I'm doing this test with a normal thing, I would be looking for, I'd have to be outside of 1.96. And so what would I do? I would take my sample, x bar, I would subtract the mean, and I would divide by the standard deviation. Okay? And this would give me a calculated number. And if, let's call this, I don't know, what do we want to call it? Let's call it little c. If c is bigger than 1.96, or if it's a negative, if it's more negative than 1, if it's bigger than 1.96, that's telling me I'm out here. I'm going to take that as evidence of things. So what happens is I measure it, and if I'm outside of that, I say, okay, I reject a null hypothesis and I accept the alternate. I've shown change. If x is in here, x bar rather, this is going to come out to be smaller than 1.96, then I would say I cannot reject the null hypothesis, so I say that there is no significant difference. Okay? Now, let's take a similar type thing. This would be a two-sided test. What does it look like if I've got a one-sided test? Let me draw another picture. One-sided test, if I'm looking at is it greater than, I'm just looking up here, 95% over here, I would have 5% out here. I don't care about this, so this is actually the easiest test to do. And so now, the 5%, if you remember looking it up, this is 1.645. Okay, so I would still take my mean, subtract the mean of the population, divide by the standard deviation. If this is greater than 1.645, then I reject the null hypothesis and I say the mean has increased. It is significantly greater. Okay, if I wanted to test on the other end, I'd go down here, and this would be minus 1.645. Okay? The key about a one-sided test, okay, I got my 5% down here, I'd have 95% this way. Okay? So one-sided test, you group your whole error factor, the 5% or the 2.5%, on one side. Okay, so if I was doing a one-sided test for 99%, I would have 1% up here, and I would look at how far do I have to go to get 99%. I go look up 99% and get a number. If I'm bigger than that, that's telling me that I've grown. Okay, so just recapping very quickly, when you're doing the test, a one-sided test is looking, did I go up or down? Let's put this up. Okay. Okay? If I'm above, so a one-sided test, I group my whole, if I want 95%, I put my whole 5% on one side and look, did I come in above the test number? Okay? Or if I'm doing it on the other, I put it to downside. The numbers are going to be the same. It's just it's going to be negative if I'm testing less than. It's going to be positive if I'm testing greater than. Two-sided test, I don't know which way I'm going, so I have to split my error factor, it's called an alpha, between the two sides, so I have 2.5% to either side. Okay? And so it's actually possible for something to be shown not different, okay, where it didn't change, failed the two-sided test, and passed the one-sided test. Okay? So it allows you, if they're borderline values, you can come up with some interesting things. We'll talk about this in greater detail later when we get into some of the qualitative aspects of testing. Okay? But making the decision, you set this up, and this will tell you whether or not you have significant change or significant increase or significant decrease. That comes from the alternate hypothesis. If you don't, then you don't say things are equal. What you're saying is you cannot reject the null hypothesis. Your test does not show significant change. In other words, it's not significantly greater, it's not significantly less than, or it's not significantly different. Okay? You're not proving they're equal. You're proving that they haven't changed enough that you can feel confident about that change. And significance is an important thing. That's the term. Statistically significant means you got results that should not have happened 95% of the time. Thank you.